Hi, and welcome to another episode of Raw Green, a show produced by OBI, your sustainability consultancy specializing in life cycle assessment, research, and green tech. Check us out at oneobi.com or connect with us on socials. Links are ready for you in the description. Ciao! I am Francesco D'Alieto. I am passionate about sustainability and green technologies. Welcome back to a new episode of Raw Green. Industrial heat is the elephant in the climate room. According to the International Energy Agency, supplying heat accounts for almost half of all final energy use and 38% of energy-related CO2 emissions worldwide. And roughly half of that heat is used inside factories. Yet, most boilers still burn gas because the sticker price looks cheap and we're literally paying to waste clean power. Let me give you an example. In 2023, the UK grid operator had to curtail 4 terawatt hours of wind. That's about 1.3 billion pounds, according to the National Energy System Operator. Today, we're talking to Andy Johnson, Business Development Director at Caldera, a company turning those stranded green electrons into zero carbon heat with a solid state thermal battery built from sustainable materials. Ciao, Andy. Welcome to the Green. How are you?
Good morning. I'm very well, thank you, Francesco. Yeah, really pleased to be here. Thank you for the invite and opportunities to talk.
Thank you for being here. Why don't we start with you giving us a explanation on what is Caldera, what is the technology that Caldera uses, and how everything started.
Sure. Okay. So Caldera is a UK-based company, works out of a factory in Fareham on the south coast. Caldera was founded by two people, a guy, James McNaughton, and a person, Guy Winstanley. And those two people had been working in thermal energy, thermal storage for a decade before founding Caldera. But the flash of light, if you like, the moment of invention of Caldera was...
Light bulb.
Yeah, the light bulb moment came to James one time in 2017. And the two, Guy and James, went straight into the factory as James got Guy woken up to say, we need to try this idea. And they trialed out the materials and the notion of what the thermal storage idea could be. That was in 2017, and from there the business has grown to what it is today, which is a business focused on, as you said, capturing those stranded electrons and helping them be usefully deployed to decarbonize heat. Between then and now, the company's moved through the development of a product for domestic. First several years was taking the concept and building a domestic product, which was deployed, went into a whole series of homes, and is still there today, actually, operating very, very successfully. But what happened was the marketplace for domestic really looked quite challenging from an economic point of view as we're headed into the energy crisis, the war in Ukraine. Then it didn't look particularly attractive, and that caused the business to pivot, if you like, and to look at the opportunity to take the same technology but focus it on industrial, where the business believed there was more opportunity in the near term, let's say. So that's what happened, and from about 2021, the business was looking to think about how to address that industrial market and scale up what was by then proven technology. And so 2022, 3 and through 24, the business has been developing the technology to the point we are today, where we're now selling a product into the industrial landscape. So we're in that happy place. Coming back a stage or two, I talked about the flash of light and the technology. And you mentioned in your introduction that the business uses sustainable materials to store energy. The concept is essentially using two very readily abundant materials and importantly, very cheap materials. That's volcanic rock and recycled aluminium, so scrap aluminium. We don't really care what grade of aluminium it is. There's a lot of engine blocks now being recycled that aren't
Oh,
going to be required in the
yeah.
future as we head towards BEVs. So those two source materials, which are abundant both here in the UK where we've started the business, but also importantly for the future, are going to be available globally to a business that scales, are the two core ingredients of the product. They both got very good specific heat capacity. The aluminium's got very important thermal conductivity, and they are essentially the core of what we store energy in. Now we store energy as heat, but we generate that heat electrically. So we're taking resistive heating elements, using those to generate heat and store that energy in those two materials.
Let me ask you about, so basically the volcanic rock and the recycled aluminium, they compose the heat cell,
Yeah,
right?
that's correct.
Uh, so why? Why, besides, let's say, the availability of raw materials, which both, I mean, it's plenty of volcanic rock and it's plenty of recycled aluminium, but do they have some specific performance metric that make them, let's say, the go-to choice for materials to develop a heat cell?
Yeah, well, in thermal energy storage, folks are tackling the challenge in a number of different ways. We've chosen as a business to work in the sensible heat range, so we're not interested in phase change. Phase change is interesting and great technology and probably useful in other areas of thermal energy storage than we're trying to tackle. We've chosen to use these two materials because they're stable. They've got great specific heat capacity, and we can get a lot of energy stored in a very small footprint. So that's really the core rationale for the choice of materials. And they're, as we said earlier, they're readily available. And they've got the properties that mean that they don't deteriorate over time. We're going to heat a thermal store up and cycle it many, many, many times over its lifetime, which, by the way, is pretty long.
Yeah.
And those two materials don't exhibit any sort of properties of deterioration over that kind
Deterioration.
of
Yeah.
performance requirement.
Talking about, let's say, the choice of these two materials also determine what kind of performances obviously you're going to achieve. So
Yeah.
what I wanted to ask you is in what kind of temperature ranges does the Caldera tech operate? And if you don't mind, tell me, what is the application sweet spots? Where do you picture the perfect Caldera project site?
Yeah. Okay. So I mean, as I already said, we've chosen to work in a sensible heat range, and we will charge the store up to 500 degrees Celsius, and we'll discharge energy from the thermal store, running that temperature down to about 250 Celsius. The lower temperature is really a function of what does the customer need. Okay, so if they need lower temperatures, then we can run a little bit lower ourselves, but we need an operating range. So that's the operating range of the store itself. What that means is we can provide to our customers an output in terms of heat up to about 16 bar steam. So that's about 204 Celsius. And addressing your question about the sweet spot, that then gives you a kind of a sense of what our upper limit in terms of sweet spot is. So it's folks who are using steam and steam temperatures, importantly, in their business for process heat or whatever use they have. That becomes our upper limit, and we can run down to any particular output heat temperature that the customer might need. However, we do believe that when you get into the sort of the lower warm and hot water temperatures, then that's not really the sweet spot for Caldera. There are other technologies that are great efficiency and give a great return to a customer, like heat pumps, and we think those sorts of temperature ranges up to sort of, let's say, 90 Celsius are gonna more often than not gonna get satisfied by heat pumps. Whereas as you go through the transition into steam temperatures, that's when you start to transition into the applications where our product, sometimes in combination with others, is going to make a lot of sense for folks.
That was one of my questions, because you can talk about the best application case, but there are also cases in which, let's say, you have to turn down the project because let's say the request, it is not compatible with the tech that Caldera it's offering. So
Yeah,
let's say that the temperature, the water temperature, it is one, or let's say in terms of efficiency, like heat pumps, which are phenomenal.
yeah,
They have a phenomenal COP. It is something that in Caldera in that will not get into.
yeah,
Sorry.
yeah.
But there are others, maybe super high temperatures. What about above the 500, 250 or 500
Yeah,
storage?
and folks in other, if you like, technologies within thermal energy storage are going to be trying to tackle those sorts of temperatures.
Mm,
We've chosen to limit what we're trying to do, and it is a function also of the physical properties of the storage technology itself. We're not going to be able to satisfy those super high temperatures. Bear in mind, we only take our own store up to 500 Celsius,
yeah.
and then we need an operating range below that. I suppose it's really important to say that whilst it sounds like we're limiting ourselves, you've already talked about the size of the thermal um, challenge, if you like, in industry. Um,
Hmm.
Bear in mind, from the numbers you've just described, that about 40% of all of the heat that is required in industry is below 200 degrees Celsius.
There
So
you go.
it's not
Yeah.
like we're not talking about a big market
No.
that needs an answer. We believe our technology has got a huge market to support and to address, and actually is probably the more readily addressable because of the simplicity of the technology, um, and probably the challenges of addressing that market when it comes to temperatures and the effects of temperature are going to be a little bit easier than when you start thinking about thermal storage for much higher temperatures.
Mm-mm-mm. So, if you want to list, let's say, your top three industries that, for example, you as business development director are targeting
Yeah,
right now, which one would you list?
yeah. Well, they fall into, as I've said already, anybody who's sort of working in that temperature range, and that, let me give you a bit of a slightly longer list, but not much. Food and beverage is probably one of the biggest categories that we see as an addressable market for ourselves. That's
Mm-hmm.
food, all the beverage industries like distilleries, breweries, and soft drinks. Um, the pharmaceutical industry is also an important category for us, we think, and also things like the paper industry have all got heat
Mm-hmm.
in that same zone. Now, those are three very obvious sort of categories. There are others out there that are also using steam, probably smaller in terms of sector in our eyes, but they may be using different temperatures as well. So
Makes sense.
there's a big wide spectrum that we think is within scope. It's probably also important to say that whilst I think both industry and the commercial sector are thinking very carefully about how to de-steam and bring the, if you like, the heat temperature load down into more accessible ranges for heat pumps, and that's moving forward quite successfully. It's also true to say that heat networks that need to replace existing steam networks sometimes find that very, very challenging to do because of the cost of
Expensive.
ripping out
Yeah.
an old steam network to put in a new network to distribute heat.
Mm-hmm.
We've found some business cases where it makes sense for the customers just retain the network they've got and find another solution to get steam across to the user locations using the steam network. So I would say networks are also an important category, and in fact, our first deployment going in this year is actually steam into a heat network for a non-industrial. So, in spite of what I said about the target market, our
Are
first,
we talking about district heating?
yes,
So is that what you're saying?
effectively as district heating network, yes.
Yeah. Wow.
Yeah.
That's very interesting. It,
So
it
it's
was on
very, yeah,
my list of 500 questions for you. If
yeah.
there
It
was,
wasn't our first most obvious customer, but they popped out a little bit earlier than we were expecting. So we're
it
pleased.
makes sense though, and
Yeah,
if you have that centralized and then dispatched
yeah,
form of heat, manageable heat, it does make sense in terms of efficiency,
absolutely.
and price, final price for
Yeah,
users.
yeah,
Obviously, I mean, from a regulatory permitting perspective. It is a pain in the bum, let's be honest, but probably worth in the long term, very, 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 very much. Since I have you here, let's talk about some economics, if you don't mind. And more importantly, I would like to talk about, let's say, a comparison between, let's say, a sustainable form of thermal storage as calderas versus fossil heat. Okay, let me give you some numbers here. So in the UK, the average Q3 2024 manufacturing prices were 3.7p per kilowatt hour, and for natural gas, sorry, versus 17.9p per kilowatt hour for electricity. In the US, let's go on the other side of the pond. In 2023, they paid around 1.5 cents per kilowatt hour, while for electricity, it was 8 cents per kilowatt hour. Now, having said that, how are we going to justify the economics in, let's say, electrifying heat?
Yeah, it's a great challenge, and that is what you laid out is the obvious reason why industry is just not racing towards ripping out their gas boilers and putting something else in, like a direct electric boiler right now. And it is technologies like storage that are going to provide one of the, if you like, the keys to unlock that challenge, right? So the spark gap, the price spread between electricity and gas is the barrier, and we believe we've got a technology that helps move past that barrier. Because
I'd love also to add fossil without subsidies would be more a level grounded play area. So that will probably should be subject to consideration.
Cool.
But nonetheless, that's where efficiency kicks in.
Yeah, we've got to recognize that the world is changing, and that's, I think, from our perspective, very, very positive. So I would describe probably three ways where thermal storage, the Caldera product, is going to help people address the challenge that you've just laid out. The first, if you like, application is where a customer's got opportunity to lay out their own direct wire renewables. So that means putting in typically ground mount solar, but potentially wind, but really ground mount solar is probably the lead, and it's the cheapest available renewable technology that you're ever going to find, and the costs continue to go down. It's staggering how fast solar has dropped in price, and it's staggering how much it continues to drop in price. And where we find customers, clearly this improves the further south you go across Europe, which is sort of the market we've been looking at so far. Where we've got customers who've got access to put in their own direct wire ground mount solar, then we can achieve a business case that makes sense for those customers and get into not only price parity, but a cost-effective solution to take the customer's energy costs down. Because after you've factored for the efficiency losses of gas boilers and then actually you get into that situation. So there's the first user case, and that's where we believe we're going to be starting to see most of our customers in the very, very short term. The second, though, is quite interesting, which is a lot of folks understand the multiplicative effect of a heat pump and are working hard to think about how to deploy heat pumps to get the leverage, which again helps address the price gap. What they find as they look at it is that there tends to be an area in the steam sort of temperature range which is hard to address with heat pumps. It becomes expensive in terms of technology if you're trying to get into that zone. So you kind of put in a couple of phases of heat pumps, you put in some MVR, you get into low steam pressures, but you're not quite actually delivering the pressure levels and the temperatures that you need. That's one scenario. But and we're working on a number of projects with heat pump suppliers to generate a combined project that satisfies the entire site heat load. So if you like, the combined effect of heat pump, MVR, and Caldera, when you look at the overall COP, the overall efficiency of the system, it gets the customer all the way to bright, in spite of the fact that effectively the Caldera technology is, let's call it a 1-for-1 efficiency, a little bit lower than that, but not far off 1-for-1. But if you apply, if your goal is to fully decarbonize, then we can add to a system that's already conceptually going to take the lion's share of the heat load and actually complement it with topping off the steam load. One of the reasons why technologically that's quite an important notion as well is that what you find with heat loads for factories is they tend to be quite spiky. Not always, but very often they're quite spiky, and oftentimes the heat pump and MVR technology would love to be able to deliver that load, and it's got the capacities, but it likes to be flatlining, doesn't like to be trying to follow a load. And when in combination with a Caldera system, you've actually got the technology that actually delivers base load and then can follow the load. So there you go. That's a bit of a long-winded explanation to the second kind of bit.
Don't let anybody stop you.
Yeah, okay. And then the third area where I think it's going to be getting more and more exciting, and it's just beginning to sort of lift off the ground, is this whole area of demand response to capacity markets, balancing services on the wholesale market. There's a revision to some of the regulations now that means there's much more opportunity for players to get into that zone. Only to affect the retail contract that a particular customer's got set with their existing energy supplier, but provide the services because you've now got if like a switchable device that can play in the market, and that can bring quite a bit of value back to the customer to help bridge the gap between their notional electricity price and the gas price. So some of the folks we're talking to today look very interesting when it comes to the customer that can't get all the efficiency and all of the justification together yet. Suddenly, I've got a device. There's a base value to that for Nesso to sort of have something that they can switch on and off, and then there's access to the wholesale market. You can target times when you want to charge, etc. When the wholesale's going zero or going negative. Yeah, I mean it's quite interesting to see how much the wholesale market is moving. I think last year it was just shy of a couple of 100 hours. The wholesale market was either zero or negative. Forecast, if you go forward to 2027, that's forecast to be 1,000 hours. Yeah, so 5 times more of the whole year. So what's that? That's about a 12th of the whole year. The wholesale price is forecast to be either zero or negative. So all of a sudden, having the technology in place that's going to customer access to that kind of pricing is going to be interesting for folks.
Let's be honest, though. We're talking about a underserved distribution grid.
Yes.
Management of the distribution grid. Because, I mean, if you let's forget for a second about grids and electricity and heat. If you think about fast-moving consumer goods, right? The how capillary and how well it is the distribution network built for a supermarket chain or for another, I don't know, any other kind of retailers in the fashion industry, whatever. Okay, if you want to use this metaphor of the distribution for fast-moving consumer goods into the energy space, you suddenly realize how understructured the energy part is, especially for what? The logistic, which is storage. So if you want to, I know it's a stretch, but I really hope it gives an idea on the amount of work that needs to be done at storage level, both electricity and energy, to be able. It's not just about the renewables or the spike in renewables. There are so many things that happens all at once. The COVID first, and which changes the peaks in energy demand. Then you had the war in Ukraine, and then you have have something that's going to happen. Now people are panicking, talking about renewables because what happened in Spain and Portugal a few days ago. The management of the distribution of the storage part, it has to be more and more pushed on the agendas at grid level, national level, whatever it's going to be. What I wanted to ask you, it is, you talk about service and cost, and I have one big question, but before that I have two small questions.
Go for the small one.
So let's go for the small one. When we talk about levelized cost of heat, in this case, against a natural gas boiler today, what is the key components in the overall balance of the system that makes the difference? Is it the initial capex? Is it whatever the project cost? What is it?
Yeah. Okay. So really, it's if we take what I was just describing earlier and the components, the ingredient costs of the electrons, right? Those are the most important part of the equation for the levelized cost of heat coming from electricity. Okay, without a shadow of doubt, our job, Caldera's, is to absolutely minimize the cost of the storage technology so that the incremental cost of, if you like, handling that electron, holding on to the energy that it delivered, and then making it available to the customer is the absolute minimum. Yeah. And that's what drives the, if you like, the mentality and the logic of simplification of the technology for storage, low cost ingredients. It's like making a cake, isn't it? Low cost ingredients in terms of the manufacture of the store itself. If you get those factors right, and also the cost of what's importantly sometimes forgotten about, but it's very important, the balance of plant required to put the technology into a site. If you get those ingredients right, then the cost per megawatt hour delivered via storage is minimized. Now, so that's our role. We do that through some of the ways I've just described. What's also important is the application. So if the storage technology is cycling a lot, then clearly you're putting more energy through the asset, and therefore the cost per unit delivered at the end of the day is going to be lower because you're putting more energy through an asset that's got a fixed cost.
Depreciated fast. Yeah.
So they're probably the important bits. What I think we've got with the Caldera design is a product where, as I just mentioned earlier, the balance of plant has been carefully engineered to be as integral to the product as is fundamentally possible.
Almost plug and play.
Yeah, so it's a plug and play solution. What is true in some, I don't mean to be overly critical of, if you like, competitors in the same market, because
you can insult them. It's fine.
Going to be needed in different regimes with
they're going to be happy
solutions.
Yeah.
The Caldera solution is quite clever in that the technology to get the energy in and the technology to get the energy out is integral to the product, and therefore the balance of plant is absolutely minimized, and you can just plug and play, as you said. So we just need the tails from the site's network, from the site grid, 11 kV tails bring into our RMU, and we need a flange or two to take water and then deliver steam, and those are the two plugs, and connecting those up, you can now play. So those are really some of the important variables, I suppose.
And if I, let's say, this, I own, I don't know, an industrial plant, I need heat, you tell me this and I say, it looks too good to be true. That's my second little question. What about O&M?
Yeah, a great question. The engineering manager on most sites that I've ever run and that I meet nowadays, they hate their gas boilers because they're expensive, they require manning, they require downtime for maintenance, etc., etc. With the thermal energy storage solution we've got, it's essentially an inert being. The only moving parts are really the pumps that push water into the thermal store in order to get superheated steam out the other side. Beyond that, there are no moving parts, and secondarily, there's no big no big vessel with a huge charge of very, very high pressure, hot water inside. So the explosion risks go away. All of those sort of, if you like, challenges of managing within the pressure regs, we take those out of the system. So you've got a very inert product with essentially an inspection regime rather than anything significant when it comes to maintenance to do. So it's really external visuals, but none of the same sort of layers of compliance that are required for a conventional gas boiler.
Okay. This, again, it all sounds amazing. So I have to ask you this thing, because if you have a proven and bankable technology, I believe there is one thing that it has to be a must for any energy tech, whether it is electricity or whether it is heat. In your case, it is heat as a service, or let's say in heat service companies. Okay.
Yeah.
So it is something that it absolutely destroys or eliminates the cost barriers with the final user. It gives some sort of comfort from the user side, because it is the tech provider that invests into the asset and also manages throughout the life. So you have some sort of, if I were an industrial user, I would feel very much comfortable, because basically you take most of the risk. I pay you the right amount of money, but you are with me. You have skin in the game. You're not just doing the installation and then thank you, bye-bye, I'm gone. And I'd see you once a year to do the O&M or whatever it is, the frequency. Okay, so I really think for any tech that it is proven and bankable, so you have that financial partner to help you to deploy the largest amount of projects possible, it is a must. Okay.
Yeah.
Is it something that you guys are working on?
It is indeed. I wouldn't disagree with any of your points, actually, Francisco. I think we're transitioning. We're creating a technology that allows a transition into a world of heat as a service, for sure. I think we're coming out of a world where traditionally the site operator has wanted to own those types of assets, probably less interested in owning a solar field next door to their site, but we're always more likely to own their own gas boiler and boiler house and boiler operation. And now we're moving into a world where our product is much more like a battery you plug in, and then it opens the mind to exactly what you just described, which is actually, I don't really need to think about this asset anymore. You guys can take on the investment risk and et cetera. All I want is the output from your product. I know it sounds strange, but I think the difference in technology is opening up people's minds to that. And so, yes, we are talking to a number of players about their opportunities to provide. And typically they'll provide heat as a service, and typically they'll be folks who are providing energy as a service, and they're increasingly seeing that they've already got customers who they provide
really have access
electrical energy as a service via whatever means, but they realize the customer also uses heat. Well, we could do all of that rather than just the electrical. So I think that's we're starting to see that right now.
It is. It is something that I've seen it with the LED. I've said it before. I've seen it with LED, and it just on the lighting part, it was the numbers were phenomenal. We're talking about few years ago. I might look very young, but this was several years ago, and the price of LED was horrendous at that time. Now they're cheap as hell, but and it works. It absolutely works. So again, as you've noticed, I don't like numbers at all. But what I would like to ask you, it is you recently built a 4 megawatt hour industrial demonstrator in Fareham in the south of England.
Yeah.
Can you give me some numbers on the performances of that?
Okay, yeah. So we did. We've built a demonstrator unit, 4 megawatt hours. Just to contrast that, our standard product that we're selling into the market is 5.3 megawatt hours of storage. So it was a smaller unit for our first demonstrator. We're now sort of replacing that and putting in a 5.3 one. In a customer site, that unit, the 5.3 that we're selling now, can be charged at up to 2 megawatts. So we can take 2 megawatts into the store, hold 5.3 megawatt hours of energy, and we can discharge at 1.3 megawatts of heat out. If you took energy into it, stored it at 500 Celsius, and left that store for 24 hours, we will lose some energy, we'll lose some heat through primarily conductive losses. What I didn't describe earlier is that we look after the energy in the store with effectively an inverted thermos flask. So we manufacture a twin-walled steel cylinder which we drop over the store and pull a vacuum. And that, believe me when I say, if we were charged to 500 Celsius inside the store, you could touch the outside walls of the store and not know whether it's hot or cold inside. It's so good.
Interesting.
However, we still lose some heat, and that's mostly conductive losses through the base of the store,
All right.
rather than anything else. So
what's it made of? Was it concrete?
The base is steel,
steel.
And it's engineered to minimize those losses, but there still will be some conductive losses. And so 24 hours later, charged at 500, we lose about 4% of the energy that we've stored. And that drives you to think, actually, we should be trying to cycle it. Well, we see the application is all about cycling the store anyway. So 4% over 24 hours is a bit of a maximum. Another way to think of the characteristics of the store is if we took energy straight in and straight out the other side, which you can do, then the straight through efficiency is around about 98%, which benchmarks extraordinarily well. If you compare that with a chemical battery, then we're probably beating a chemical battery. And I think folks kind of get a little bit surprised when I say that, but actually that's the case. It's quite interesting.
Very interesting. So was this the thing that surprised you the most on the demonstrator project?
I think what surprised me, and I think is a very important characteristic which helps us now as we're thinking about the applications of the product, was actually the thermal reactivity, if you like, the response characteristic. So I described earlier that we've got a very low mass of water that we're dealing with when we're taking energy out of the store. Unlike with the gas boiler, you've got a huge volume of water there. And it's that fact that means that the store is very, very responsive when we need heat. We've got a very small charge of water that's at temperature. The heat exchanger that we deploy through is at temperature. You turn the pump on and squirt a small amount of water into the store, and all of a sudden you're throwing huge amounts of heat out the other side. And I think that characteristic is probably the most interesting when it comes to the performance of the product itself, actually.
Very interesting. Very, 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 very interesting. Is there any commercial contracts you can talk about? Some specs, size, sector, headline economics?
I think
something crunchy.
Probably I can't go into specific contracts that we're working on with specific customers, but I would say, I was talking about the food industry and the likely economics of projects there. We've got clients that we're talking to with direct wire solar, and they can achieve, when you combine the solar and the product together, you're getting to a sort of a sub 5-year payback, and that's in the UK for a product that's going to, because it's solar and you're dealing with the shoulders of the season, are going to help folks decarbonize their sites sort of in the 70 to 80% range. So that's really, really interesting characteristic. Now, if you layer that with what I talked to you about earlier about the balancing market, capacity markets, etc., then will in future then present the opportunity to help deal with the shoulders of the season when solar's not doing its work. So yeah, there's really interesting cases like that, or with a couple of projects where sites have already de-steamed and deployed heat pumps and have got very, very poor efficiency out of the residual load satisfied by gas boilers. And again, those business cases are fantastic. Actually, you're talking 3-4 years, and you've got yourself something that deals with the rump of a carbon fossil-based solution as was. We've tidied up the job that they've set out to do in the first instance. So yeah,
Very interesting.
quite interesting.
You kept yourself quite busy. I read on the news that March, something like that, March 2025, this year, this planet, you closed a Series A with 10 million pounds from GEA Group.
Yep.
Why were they the right strategic investor? What doors they help open or have already opened?
Well, first thing to say is GEA have a connection that I think has emerged out. I described to you my old world in Innocent, and actually that was where I guess I got to know GEA very well, because they were a big supplier of both the process equipment and the energy solution for the factory that we designed and built there. That connection has led into GEA coming to understand what Caldera is and the technology that we have. And for them, and I guess as I described earlier, we represent a technology that is of high interest for them when they're trying to talk to their customers about full decarbonisation solutions. Yeah, they do the heat pumps. Yeah, they do MVR. But what about the top end of this? All of a sudden, they've now got answers to how they can offer that solution, and we're working together on projects that do just that. So they see us strategically as very important, and have therefore chosen to
implement
invest in the business. And likewise, we think we bring potentially other categories into, if you like, the sights of a business like GEA over time. So we're attractive in two directions. Both technology-wise is interesting for existing, if you like, customer base for GEA, but also potentially there's some new customers that they wouldn't be working with without us leading into
mutually
it.
Beneficial.
There's
a lawyer would say,
and clearly they're a big engineering business, so they've got skills and competencies that we can learn. We're a small startup essentially, so we can learn a heck of a lot from a business like GEA. So they bring that into our, if you like, into our range of opportunity as well.
And to be extremely unpolite and dig a little bit more inside your business, well, how's the cash is going to be split? Is it going towards R&D, business development?
Yeah, a mixture of things really. Some of the money is helping us invest in capability internally for capital investment, and some of the cash is going to be helping
production
from a production and cash flow point of view as we scale our projects. Then there is a little bit of a dip in cash going out before cash comes in, so that it works in that way as well, of course.
Wonderful. Let me finish this episode with something we recently started to do, which is a quick fire wrap up. Okay, just three questions, just very short answers. So number one, most common myth you like to debunk about thermal storage?
It's more cost effective than the folks I talk to realize it can be.
Okay. One ask you have for potential industrial hosts listening today?
I think my ask would be for folks to start with a destination in mind, which is electrification. Discard all the other noise that's around about trying to burn other chemicals, other molecules. Start with electrification and think forward for the world as we started this call, actually, the world is changing. The price of electricity won't always be that constant flat line that you think it is. There's ways to find low cost electrons to satisfy heat load.
Savings are everywhere.
Yeah.
Okay. Last but not least, if you could wave a policy magic wand, a wand, not a hammer, okay?
Yeah.
What single regulation or incentive would accelerate industrial heat decarbonization the most?
Wow. Crikey. Well, if it was my magic wand, I think there's a number of things I think you change in the electricity market. However, the biggest one I think that would be an unlock, because we know that the wholesale market is variable and is going to give access, is the transmission and distribution costs.
Good.
And if that became variable with alongside the wholesale market, then that's a massive unlock.
Yeah.
So today we pay 10p a unit just to get the electrons from where they're made to where we need them.
Yeah.
Make that variable and open it up for when we've got spare and we need to consume it into storage. And again,
virtual power plants, virtual heat power plants. Yeah, makes sense. Wonderful, Andy. This was fun. Thank you so much for answering just part of my 500 questions, just to be clear, okay? But this is very interesting.
Kind to me. Yeah.
Was I? I absolutely like your technology, and there is one more thing that we haven't talked about it, or maybe you said it and I wasn't paying enough attention, which is the modularity of the technology, which I absolutely love from multiple perspectives, capex requirements, efficiency, blah blah blah. But again, thank you very much, and we'll catch up soon.
Yeah, it's been my pleasure. Thank you very much, Francesca.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and the green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!